Okay. So we are going to start at 6:45. We will wait for 4 more minutes. So hello everyone. I'm Kumar, second year undergraduate at IIT Bombay. On the behalf of Ham Radio Club IIT Bombay, I would like to welcome you all to the online ISS tracking session. Today we are going to track the ISS, and after that we are going to decode the tracked signal using the decoding software. So what is the ISS? So International Space Station is a habitable artificial satellite. ISS is a science laboratory in which the astronauts and the scientists live. The time period of the ISS is 93 minutes, so it revolves approximately 16 times around Earth in a day. The ISS is not launched by any specific space agency. It was launched by the multiple space agency. The space agencies of Russia, USA, and the European Union space agencies. The ISS transmits signals at the frequency 145.80 megahertz. So we have to receive the signal at 145.80 megahertz. So this is all about the IS. So why ISS is transmitting the images? So there is a program called ARISS, Amateur Radio on the International Space Station. In this program, the students and the mature enthusiasts can connect to the astronauts and can talk to the astronauts. The astronauts through the ISS also transmit the signal several times in a year. The enthusiast can track the signal and after that can decode it into the images and useful information. So this is all about the ARISS and now this is today is the 20th anniversary of the ARISS, so that's why ISS is transmitting the signals and we are going to decode the signals. So ISS is transmitting the signal, we have to receive the signal. So to receive the signal, we have to track the ISS. So, what is the satellite tracking and how we can track the ISS? So, satellite tracking. So, to understand the satellite tracking, we have to understand why we send the satellites in this space. So, we send the satellites in this space because, like, to collect the information about the outer space, about the Earth, about the atmosphere of Earth, the oceans, and for the communication. So satellite receive and collect that information and after that it transmit the signals to the earth. So the process of receiving these signals and like finding the useful information from these signals is called the satellite tracking. So when we do the satellite tracking, we need some equipments and the hardwares. So, and we need a specific setup of the equipments and hardwares, and that's why we build the ground station. So, what is a ground station? So, ground station is a radio station on the surface of the earth, and in the ground station, we have a setup of the equipments and hardwares we are going to use in the tracking process. Here you can see the images of the ground station we have at the time of the launch of Pratham. Pratham was the first satellite made by the SSP team and IIT Bombay, and it was launched by the ISRO. In these image, you can see in the right image there is the antenna, and we can rotate antenna and according the satellite and the location of the satellite. In the left hand side, you can see the image of the control room where all the hardwares and the equipments are placed, and they are set up in a special like circuits, and this whole setup is called the ground station. So if we have ground station, we are going to track the satellites. So the tracking process is divided into three parts. So the first part is pre-pass, then real pass, then the post-pass. So what is the pass? So pass is the time when satellite or the object like ISS passes over our location. Like satellite is passing above our location, then that time is the pass when we receive the signal. So we divided the process in three parts like pre-pass, real pass, and post-pass. So the pre-pass process, in the pre-pass process, we find out the information about the pass, the starting time of the pass, the ending time of the pass, the maximum elevation that the satellite achieve, and all other information that we need to track the satellite. And the find the location of the satellite and path of the satellite in the space. In the real pass part, we already have information about the satellites. So in the real pass but we are going to track the satellite. We are going to receive the signal from the satellite. After receiving the signal, we go in the post-pass phase. In the post-pass phase, we already have the signal. So, using that signal, we are going to decode that signal in the useful informations. That called the post-pass process. So, after that, like we know about the what is the tracking and what is the tracking process. We have to do the satellite tracking. We have our own ground station, and there is the tracking process that is divided in three parts. So what is the right time for tracking? Like we want to track the satellite, but we don't know when to track. Like you can't track like I want to track now, and I am going to track and I will receive the signal. I will not receive the signal at any time. So that's why we have to find out the time when we track the satellite. So we can track the satellite when satellite passes above our location. When the satellite passes above our location, we will surely receive the signal, and we can track that signal and record that signal. So, as you can see in this image, this is the depiction of the satellite, and this is the our ground station. You can see this is area of the red circle. In this area, the signal of the satellite is available at that time, and this yellow line shows the trajectory of the satellite. So now we know the like when we do that we do track a satellite. Now what is a pass? So as I told, like pass is the time interval in which we are going to receive the signal, the time interval in which a satellite is going to pass above our location. Because as we know, like satellite pass revolves around Earth, and it will pass above a specific location in a specific time interval, and that time interval is called the pass, because only this time, in this time interval, we are going to receive some signal. So in this image you can see this black line is showing the pass of the satellite, and it starts somewhere in the southeast direction and it will end in the northwest direction. You can see this is the horizon and this is your ground station, or you are observing the satellite, and the axis perpendicular to the horizon is called the zenith, and the circle passes as the taking as north south axis as the diameter and passing through zenith is called the meridian. So this is all about the like when we saw the satellite, we have to know about these things, and at this time the satellite is here. So the angle between the line joining to the ground station to the satellite and to the horizon is called the elevation or altitude. So this is the elevation or altitude, the angle made by the satellite at a specific time. And one more thing we have to know about when we do the tracking process is the azimuth. So how can we find the azimuth and how it help us? So we find azimuth by taking the projection of this line on the horizon plane, and the angle between this line and the north direction is called the azimuth. And we measure the azimuth in the clockwise direction. So we measure the azimuth in this direction. So this is how we can find out the elevation and the azimuth. Now, how the elevation and azimuth are important in the satellite tracking. So if we know the elevation and azimuth, we know the exact position of the satellite in the space, like which angle from the north and how much above the horizon. So we know the location of the satellite. Then we can also find out the path, like this path, like from this path is the satellite is going to pass. So we can point out our antenna or the equipment we had in that direction and receive the signal. So this is about the path. Now we know about the path, the tracking process, the what is the satellite tracking. But how we can find out the path? Like when the satellite passes over the horizon or our location, we can't see satellite passing because satellite is very small. We can't see the satellite. So how can we find the pass? So for finding the pass, we have some website and the softwares. So we can either use the n2io.com or we can use Orbitron. So what is the difference between these? And the thing to remember is we can use this or this. These are the alternative of each other. Like either we can use n2io or we can use Orbitron. You don't need to use both of them. Okay. And so what is the n2io.com? n2io.com is an online website that provide the information about the passage. It provide the information about the starting time of the pass, the maximum elevation and the ending time of the pass and other information about the pass. So that information can be found on the n2io.com. It is a online website where Orbitron also do the same thing, but it is a offline software. Today we are going to use the n2io.com, but I will also tell you about the Orbitron, like basic thing about the Orbitron. If you want to know more about the Orbitron, you can contact us after the session. So today we are going to use only the n2io.com, so you have to bother only to n2io.com. Don't bother about the Orbitron. So, like we have pass, we find out the pass using these website or the software. So now the time for the real pass is coming. Like that was the post pass thing. We are finding the pass, we are finding the location of the satellite, etc. Things are the pre pass thing. Now we are coming in the real pass thing. So in the real pass thing, we have to do the tracking. So in this like phase, we need our ground station and our like pass information. So we can do the tracking in two modes. Either we can do in the offline mode or we can do in the online mode. So in the offline mode, we have to have our ground station, our own ground station, and the equipments and hardwares like this is the handheld radio. You can also say this walkie-talkie, and this is the antenna. And you have to like you have your antenna or the handheld radio. You receive the signal using that antenna or radio system. After that, that will go in the SDR. SDR is the another hardware that is used in this process. And after that, the signal will go in your like PC or the laptop where you have the SDR sharp software. So that will process the signal and you find out the demodulated signal. And this is the image of a offline tracking session we have before this COVID pandemic at the IT Bombay. And like this is all about the offline tracking, but we can also do the online tracking. And online tracking is a replacement for the online tracking, and it can be much more than that. Like the first question is why we need online tracking. If we have our ground station, why we need online tracking? So how we come to know, our club come to know about the online tracking, due to this hard time of the COVID-19, we don't have access to the equipments and the ground station. So that's why we are unable to track the satellites. So we come to know about there are online platforms, website that provides the signals. Actually, they themselves track the satellite using their offline system and the offline setup. After that, they put that audio signal on some websites, and we can access to that websites and find that signal. So this is included in the online tracking. So we started using the online tracking. The other thing about the online tracking is if you are new in the amateur community and the ham radio community, you can do the online tracking because in the online tracking you don't need to have the hardware, you don't have to spend the money, you have access to so many ground station in the online tracking. If someone is receiving signal and putting his signal on some website, then you can access to that. Like this you can access to so many ground stations. So that is the benefit for the online tracking. And if you are new to the community, you first try out the online tracking. You will be familiar to the online tracking and the tracking process. After that, if you are really interested, then buy your own like hardwares and equipments. After that you can build your own ground station and do the offline tracking, or you can be switched to the offline tracking, so that will be a good thing. And for the online tracking, we don't need to have the hardwares like antenna, the SDR hardware, and the handheld radio. You only need to have a laptop or internet. These two things are sufficient for the online tracking. And Yeah. So, what are the benefits of the online tracking over the offline tracking? That are you have access to so many hardware. Sorry, you have the access to the so many ground station. You don't need to buy the hardwares. You don't need to spend so much of the money. And what is the benefit of the offline tracking? Offline tracking is beneficial because in offline tracking you have a good quality signal, but in online tracking, due to these website things, the signal will be little bit weak, and you don't have that much good quality that you have in offline tracking. So I told you about the mode of the tracking, so the offline tracking and the online tracking. Now I am going to tell you about the SDR. So as I have mentioned, you have to use antenna or handheld radio first. You receive the signal from that. That signal will go in the SDR. SDR hardware that will demodulate the signal, and after the signal will go in the SDR SAR. That is the software. You can download that, and this is the interface of the software SDR app that look like, and this is the hardware we use RTL SDR like after the antenna we use this hardware to demodulate the signal, and after that we can use this software SDR SAR to process the signal, and after processing we have the processed signal and we can decode that. So these software like hardware and the software are used in the offline tracking. So in the online tracking, there is a replacement of the SDR and the whole offline tracking, that is called the webSDR. So I was saying that you have some website and some platform where you can find the signals that was recorded by received by someone else and he put it on the website. So webSDR is kind of a website that used in the online tracking, and today we are going to do the online tracking. So what is the webSDR? WebSDR is as name suggests, it is a SDR, and web means on the websites. So in the WebSDR there are so many SDRs across the world, and that are connected to some server, and that is called the WebSDR server, where you can find the so much of the ground station, and you can access to that ground station. So this is like the webSDR, and yeah. So I want to play some signal from a webSDR, and you can hear that signal. So the webSDR is similar like you have FM radio. You can you can receive the signal from the FM radio. Using the FM radio, you have some frequency range in which you can receive the signal. But on the WebSDR, you have so much of the modes. There you have on the mode. Here you have FM, AM, USB, LSB, CW. There are so many modes. There are so many channels, and you can tune to any channel you want to tell. So you can select from here like AM mode. I selected the AM mode and I have muted it, so when I unmute it, it will give some sound. So this is similar to the FM. You can see like you can receive the signal, and but it is, Yeah. So this is much more than the webSDR. Like it is much more than the radio, because you can receive. Not only receive the FM signals, you can receive AM, USB, and other signals, and on so many like frequencies. So we are talking about the webSDR. So you can like it. I have said like it is similar to the radio, but so many channels are available and so many modes are available, and you can tune any mode and find the signals and receive the signals using that mode. So there are so many web SDRs available on the web SDR. It is the kind of the network of the SDRs, and each SDR is connected. Web SDR is connected to a ground station. So from a ground station, they receive some signal using their own offline setup, and after receiving that signal, they put that signal on the websites, on the webSTR, and where you can receive the signal. So what are the steps for tracking the ISS? So first of all, like I have said, you have to do the pre-pass thing. In the pre-pass thing, we have to find the pass of a satellite. So we can find the pass of the satellite using the n2io.com. After that, we have to receive the signal. So to receiving the signal, this is the real pass thing. Here we are doing the online tracking, so we are using the webSDR. If you are doing the offline tracking, you have to use your own ground station and this whole setup. Okay, and like after this receiving the signal, you go to the post phase phase. In that phase, you have to decode the recorded signal, and today we are going to receive the ISS signal. So we can. Yeah, today we are going to receive the signal from the ISS. So we have to use the MMSS TV software. This is the software to decode the signal of the ISS. And if for the different satellites, there are the different decoding softwares. So this is all about the steps for the tracking the ISS. And today, like for finding the pass from the n2io.com, you first have to select your webSTR using the webSTR server. If you selected your webSTR, then you can provide the location of the ground station in n2io.com, and after that you can come back in the webSTR and do the real pass thing, receiving the signal, and after that you can decode. So I am going to explain about webSTR and how can we use the webSTR and receive the signal. So this is the how webSTR interface look. So first we will do the webSTR thing. We will select a webSTR that we are going to use to today, and after selecting that webSTR, we will find the pass for that webSTR using the n2io.com, and then we will come back to this webSTR and receive the signal and then decode that. Okay, so in the webSTR there are so many webSTR available, like this is a specific frequency. If we don't choose a specific frequency, then there are so many webSTRs available. So there are around 188 webSTRs available, and 188 ground station you can access using the your internet. So the most of the webSTR are situated in the Europe, North America, and South America, and there is no webSTR in India. You can see in the map. So here, like information about the all the webSTR. So in the location and the URL column, the location of this every webSTR is given, and the URL is also given to visit the website for that webSTR. In the frequency range, there is the frequency is given, like this webSTR will tune in between 0 to 29.1 60 megahertz. And if you have to track like 25 megahertz, you can surely use this webSDR. So you can select your webSDR according, if your frequency is lying between this frequency range, then you can select this. Otherwise you can select the other, because here the frequency range is different, here different, and here also different. Each as I have said, like each WebSDR is connected to a ground station, so they also have their antenna to receive the signal. So there are the different types of the antenna available at each ground station, and they use their ground station to receive the signal. So these are the different types of the antenna available. So for example, at the Netherlands WebSDR, they are using the mini beep antenna, and the frequency range is this. So we are going to track ISS. Remember this thing. So and we know the frequency for the ISS, that is 145.8 megahertz. So we have to find the WebSDR that have the frequency 145.8 megahertz. So we can either choose the frequency band. If you know the frequency band in which your frequency is lying, then you can choose the frequency band, and it will filter out the WebSDR that have the your selected frequency. You can also select the region, like you want to track some WebSDR situated in Europe, North America, South America, and you can also provide the frequency directly. So I am going to provide the frequency directly, 145.8 megahertz. After entering this frequency, the webstrs having this frequency are filtered out, and we have like only 75 webSDR that have the frequency 145.8 megahertz. So there are so many webSDR still available in situated at different locations. Today we are going to track the South Africa webSDR. So in the Africa there is only one webSDR, and we are going to track the South African webSDR. So the South African WebSDR is available at 34 number. So we have to choose the 34 number WebSDR. So here we can see the WebSDR and the numbers are here. So this is the 34 number WebSDR, and this is the South African WebSDR. So we can open this. So it will can take some time to open. So this is the South African WebSDR. This is located in the south of the Johannesburg, and Johannesburg is in Africa, South Africa. Here you can see this is the waterfall. The waterfall is the pictographical. It pictographically shows the like signals, and here you can see like the warmer color is the signal, and this blue or the dark color is only noise. And there are so many frequencies available here, like 144, 144. So these frequencies are in kilohertz. So if you change these frequencies in megahertz, it will be 144.1 megahertz, and this is the 145.8 megahertz, the frequency at which we are going to signal today. So you can select any frequency by dragging this using your mouse. You can drag to any frequency and use that. If you don't have laptop till now, then you can like simultaneously do the things with me. So if you have your laptop, you can open that and open this webstar in your laptop, and you can start doing things. Instead of providing here, you can also provide your frequency here, like 145.800. So we have to provide in the kilohertz. So I have provided the frequency, and it automatically set it the 145. You can also choose your band, but if you choose the frequency, then you don't have to choose the band, because band is automatically chosen. You can also change the bandwidth by dragging these bandwidth bars. You can also choose any mode like FM, AM. There are so many modes are available. Now come to the audio recording thing. So when the pass starts, the warmer colors starting appear, then you can start recording. You don't have to change the volume because volume is already set to the optimum volume, and you don't have to change this. Make sure you are not muted. If you are muted, you don't receive any signal. And when the warmer color starts appearing, you can start your recording, and after the pass ends, you can stop your recording, and after that you can download your record. When the signal comes, the frequency will shift from right to left, or frequency decreases. So you can can keep shifting this from right to left when the signal comes of the ISS. So this is all about the webSDR. This is the webSDR of the Johannesburg in South Africa we are going to use today. So now we have to find the pass for this webSDR. So to finding the pass, we are going to use the n2io.com. So in the n2io.com, the location is the default location that is set is your like GPS location. So when you open this, location in this website will be your GPS location. But remember, we are tracking the web, ISS using the webSDR in South Africa. So our ground station is in South Africa. So we have to provide the location of the South Africa here. To provide the location, you first have to register on this website. So I am already registered. So you can go in the sign in option. Here you can see the register option, and I am giving you like 1 or 2 minutes so you can register. So please go in the sign in option, or there will be some register option here. And if you don't have the link for the n2io.com, then see the description on the YouTube. There you will find the link for the n2io.com. After opening the n2io.com, you go in the this is you can see here sign in or register. Click on that, and after that register on this website. So I am going like I am telling, we use the webSTR, find the location. Now we are going to find the pass, and here you have to register first. So if you are registered, then you have to log in. So click on the login, provide your username and password. After that, click on the login. When you logged in, go in the more stuff. In the more stuff, you will find a option edit or change your location. So click on the edit or change your location. Here you will find the option add a new location. So click on add a new location. Here you can provide the zip code of the country, but I don't know the zip code for the South Africa. And here you can, or you can provide the latitude and longitude in the degrees, or you can provide in the decimals. So you can search the latitude and the longitudes on the Google for the South Africa, and make sure the south is negative and west is negative. So north is positive and east is positive. And we have also provided the latitude and longitude in the description, so you can also see that in the description. I already have the latitude and longitude, so copy and paste the latitude here, and after that copy and paste the longitude here. Then click on the locate it. When you click on the locate it, this map will be opened, and you can see that my location is now Johannesburg. You can change the name from here, like Johan, yeah, like anything you want. And After that, save location and select. So now my location is set to the Johannesburg, South Africa. So my ground station is this Johannesburg, South Africa now. I can find the pass over the Johannesburg, South Africa now. So go in the home, and either you can type the name of the satellite. So here the name of the satellite is ISS. So either you can type the name of the ISS and then search, or you can wait till there will be some link will be open here, like ISS will cross your location in this time. If you directly click on that, then you will directly find out the passage for the ISS or this location. So either you can type or you can change. So it is saying the like ISS is above your horizon. It is already above. So pass is started. So we can find the 10-day prediction for the space station from clicking here. After clicking on the space station, we can find this. When you click here, you will find the passage for next 10 days. And when you click on the all passage, you will find the all passage. These are the passages that are the good enough and have the good elevation. So these are the all visible passes. When I click on the all pass, and you can see this, there are the passes, and this is the pass of like we are going to track. This is the pass. So it will start at 721. It is already started. The maximum elevation will be at 723, and the maximum elevation will be 39, and it will be at 728. So this is how we can find the pass. So we now know about the pass. Like pass start at 721 and it will end at 728, and we can track the satellite in between this time. And we know the webSDR we are going to use, so we can switch to the, now we know the pass, so we can switch to the webSDR. Here we can type the, okay, so here you can type the frequency like 145,800. We know the frequency, and we know the starting time and ending time for the pass. So starting time was 721, and the maximum elevation will be at 723, and it will end at 728. Signal is coming, so we can tune to the signal. Go in the, like that was not the signal, so signal will come in some time, and you can go in the, like you have to select the AM mode here, and you don't have to change your band. You simply select the frequency at 145,800 kilohertz. This will be your frequency, and after selecting this frequency, you have to wait till the signal is coming. So you can tune to the signal. So start tracking this, so you can start recording because the waterfall start coming. Don't have to change the volume, and don't check this mute box. So you can start the recording, and it will keep shifting from right to left. So you can shift from right to left when it keeps shifting. When you hear the good sound, then, so I am repeating once again. You have to first, when you know the pass, we know pass from the n2io.com. Then you have to put the frequency here 145,800. Then you have to select the mode AM. After selecting the mode AM, the waterfall is shown and the normal color is appearing. So you have to keep here when you hear some sound, and then start the recording, and make sure you are not muted here. I have muted my tab so you don't probably don't hear any voice or any sound. So you will hear the sound if you have not muted the tab. So after this, like now the pass is gone. You can see like the warmer color is gone and there is no waterfall at this frequency. So you can stop the recording, and after that you can download that recording. So this is 728. So I expect there will be one more pass for the ISS, and there will be the waterfall will appear one more time. So you can track at that time if you don't track till now. So we will wait till some more like waterfall will appear. Till now, I am going to repeat the N2IO thing once again. First, you have to go and register on the n2io.com. Then you have to provide your location by going in the more step, edit your location, and then provide your location, the latitude and longitude on the n2io.com. Here you can go in new location, and after that you can provide your latitude and longitude and locate it and then save it. After this, you can select the space station that will appear here, or you can simply type the ISS. Like here is shown ISS above your horizon. If it is not our horizon, then it will be showing, it will cross our horizon in this time. So you have to click on that, and then you will find the passage for ISS. Then go to the webSDR and decode. So the pass nearly ends, and we have recorded one signal from this. So now we have recorded the signal from the webSDR of the South Africa, and after this we are going to use the MMSS TV software, and we are going to decode the signal. If there is uh, yeah, so you can if you don't receive the audio due to this process, or due to, like we are uploading the video on the drive, sorry, the audio on the drive, you can access this audio and can continue to the decoding process. We are also going to use the same audio, and the description, the link for the drive is available on the description. So now I am going to take some doubts if there are doubts. So the first doubt is, what is a call sign? So what is the call sign? So call sign is identity for the amateur radio and like amateur radio members. They have each amateur radio member have their own call sign. They can, if you have your call sign, you can transmit using your call sign. It is similar like you have a mobile number for your phone, and you have call sign for your amateur radio activity. If you have your call sign, you can transmit and receive the signals. You can receive the signals, but if you want to transmit, you have to your own call sign. So the next question is, doesn't the local time mean the time of the location selected? Yeah. So the local time means that time, yeah, the time of the selected location. No, the local time means the time at our location, and it will be the, like, you have selected that location, but it will be the time at your location. So if you have selected the location of South Africa in the n2io.com, the time is showing your own time, but the location is different. So that time is time of like India, or your location's time, and your actual, like your virtual location is in South Africa. So that time is not the time of South Africa. That time is of your own location time. Do we need to install the webSDR in laptop? So you don't need to install the webSDR in laptop. You simply type the webSDR and Google search. After this, you will find the webSDR and you have to select your webSDR. So you don't need to install the webSDR in your system. Or if you don't receiving any audio, or the webSDR is not supporting your Chrome web browser, then you can switch to the Firefox web browser or the Edge browser. So Edge browser and the Firefox web browser supports WebSDR more than the Chrome browser. So I will recommend you to use the Edge or Firefox. So I am not getting that purple band on the WebSDR. So like you are not receiving the signal because of the Chrome browser, you can switch your browser, or maybe the pass was gone at that time when you are tracking. So that can also be the reason. So what is the purpose of ham license in the satellite tracking, and how can we get it? So you don't need to have the ham license if you are doing the satellite tracking. You have, if you have ham license, then you can also transmit. You can receive. No one, you don't need the ham license for receiving a signal or doing the tracking. But if you want to transmit something, then you need the ham license. And for how can we get it? So to get the ham license, you have to pass the exam of the amateur radio ham license exam. And when after you pass that exam, you will get your own ham license. So I think there are no more questions. So I am going to explain Orbitron now. You can also use the Orbitron, as I have mentioned, as a alternative for the n2io.com. So this is the how the Orbitrons looks like, and you here you can go in the location bar, set your own location here, providing longitude and latitude here. After that, you can choose the location and add to the list. I have already added the like ground station, and this is shown here, South Johannesburg ISS. So the ground station is selected here. You can provide the location and select and add the ground station or the webSDR ground station in the list. After that, you can come in the main, and where there are two modes are available: real time or this calculation. In the real time, the location of the ISS or the satellites will be available of this real time, or you can find the location at some different time or the future location. So you can simulate it, like I am simulating by 5 minutes. When I click here, it will be simulated by 5 minutes. So it will give the location of the sun. This is the sun and this is the moon. If you have selected any satellite like No 18 or ISS, then it will also give the location. The location will change when we click. It will give the location of after 5 minutes when we click. Okay, so this is how you can find, and from here you can select the satellites. So don't bother about the Orbitron. If you want to know more about the Orbitron, then contact us. We will tell you after the session. So now we have the signal. So now we have the audio signal we have received from the webSDR of the Johannesburg in South Africa. Now we are going to use that signal and decode that into the SSTV image using the SSTV software. So to decode, before decoding in the SSTV image, you have to know about the SSTV image. So to explain the SSTV, I would like to welcome Vaishnavi Agarwal. She will tell you about the SSTV.
So now that we are tracking ISS, what is SSTV? SSTV, or the slow scan television, is a way of sending images over a voice bandwidth channel that makes it possible to send images over thousands of miles. The name comes from the fact that transmitting the picture over a narrow channel made for voice transmissions take several seconds. The ease of image communication has resulted in several interesting uses, such as sending images from balloons and radio-controlled vehicles. In addition, emergency communication teams are starting to use images as tools for assessing damage after a disaster or managing public events. In simpler words, an image on your desktop is converted to an audio signal which is further converted to radio frequencies and transmitted. This signal is then received by a receiver and converted back to the original image. This protocol of communication is called SSTV. Normal television transmits 25 to 30 frames per second, while SSTV takes about 8 seconds to a couple of minutes to transfer one frame, hence the name slow scan television. Only still images are suitable for transmission through SSTV. Computer sound cards and software can be used to convert digital images to and from the audio signals used to transmit the SSTV images. For modulating the audio to radio frequencies, a transceiver is used. Then, the RF signal is transmitted using an antenna. Amateur radio on the International Space Station (ARISS) transmits images from the ISS once in a while for the ham radio enthusiasts to capture. Fast scan television also exists, which can be used by hams to send and receive full motion videos, but more on that some other time. Now let's get back to Pavan and learn how to decode the signal received.
So thank you, Vaishnavi. She told you about the SSTV images, and now we are going to use the recorded audio and decode that using the MMSS TV software. So this is the MMSS TV software. So when you open the MMSS TV software, this will look like this. So this will tell you to provide your call sign, but you don't have, if you don't have the call sign, then cancel this. There is no problem. And this is the audio strength of the signal. So the graph is shown for the strength of the audio. This is the receiver. So if you received any signal or any audio, then if you selected this RX and then play that audio, the image will be decoded. This will show the history. So I have decoded these images so using the SSTV. So you can go in the history and can see the images you have decoded. In the TX you can transmit images, but for transmitting the images you have to like you need your own call sign. If you have your own call sign, you can transmit images. And this is the template, so you can add your own template. Like I can edit the text and yeah, I can edit the text and the image accordingly, and I can change the template of the image. So now we have received the signal. So we have the business only with the RX, and before this you have to select your audio input and the our audio output if you want to like record the image. So go in the option and after that go in the setup MMSS TV. Then there are three options are available. The first option is receiver, then transmitter, and then this. So you have to click this option for the selecting your sound input and output. So, so you can select the sound card from here. So the input of the sound I am selecting here is microphone, and you don't have to select the output because we are using the RX, and for RX we only bother about the in the input of this audio. Don't bother about the output of the audio. So select the input as microphone. After selecting the audio input as microphone, you have to play some audio using the different device. If you are tracking on your laptop, then you can use your phone to play the audio. Okay, so if you play your audio in the device you are using the MMSS TV, and then MMS TV don't accept the system sound. So if you using yeah, if you playing the audio in the same device, then MMS-TV don't accept or don't take the input from that audio, and the image will not be decoded. If you don't have the another like hardware type like your phone or laptop, then you can like plug out your microphone or your earphones, and you can play your sound and then can capture that sound. Or either you can put your speaker of the earphone to the microphone of the earphone, and then the sound will go in the using the microphone. So the audio we have received today and was not that much good. So we are going to use the audio we have recorded previously, and you don't have to select any mode from here. The you have to select the auto mode, so it will automatically change to the required mode. So I have another device, my mobile phone. So I am going to play audio on my mobile phone, and I am using the MMSS TV software to record that audio. This is the audio. You don't have another device, you can same device which we are using. So this was the audio, and we have used the audio we have recorded during the August transmission. So during the September transmission, and using that audio, we have recorded the image from that audio. So this is the image we received. After that, to save this image, you can go in the history. There, this image is available. Then click the right click of the your mouse. After right click, you will see these options. You can go in this, and after that, yeah, you can save and give the suitable name to the image file. So this was the image sent by the astronauts, and you can, yeah. So we received it directly from the ISS, and there are some information available, and the call sign is also available. The transmitting the images. So the Russian part of the ISS is transmitting this image. So the call sign RS0 ISS is for the Russian part, and they have transmitted this image. So this is the call sign for that. And you can see the logo of the ISS, and these are the scientists or the astronauts at the space station. So now we have decoded the image using the audio, and these are the image received by us in the August transmission. So these are the two images we received, and these also transmitted by the Russian call sign. So this is the RS0 ISS, and in this is also. So in the August transmission, there was like 12 image was transmitted by ISS, and we have tracked that 12 image and decoded. So why? What is the purpose of decoding these images? Because this is something that is sent by the astronauts, and there can be the information in form of the text and in form of the pictures. So that's why we are tracking, and this is useful. And apart from this, the ISS also provides some uh, like if you upload these. Yeah, so if you upload these images on the ISS website, or then you can receive some prizes. So now we can take some more doubts. So yeah, so the doubt is, can you please repeat how to copy the pass in N2IU? And okay, so what to do after changing location or in N2IU.com? And okay, so more clear. Okay. So for this doubt, what to do after changing our location in the Android.com? So after changing the location in the Android.com, you have to go in the webSDR. After that, put your frequency here, choose the AM mode, and change the bandwidth if you required. And after that, you can start recording from here. Don't change the volume because it is the optimum volume, and don't mute. After this, you can download the signal, and after downloading signal, you can use MMSS TV software and decode the image. So image is not clear, how to make it more clear? So to make the image more clear, probably you have to look on your the method you are giving the input. So you can change that method, or you can increase the volume. If the volume is very, you are not getting the green signs, Like you can see at that time we are getting some green sign here, but if you are not getting the green sign, then you can also like you can increase your volume, or you can like put your mobile phone near your laptop, so that thing will can help. And if your image is not corrected, then you can click on this smiley face, and this will help you to correct the image. And if the image is slanted, then it will help you. So now the image is not slanted that much, because yeah. So these are the images received by us. Now, we don't need to resample this audio. No, we don't need to resample this audio, because like it was already resampled on the webSDR. If you are doing the like other tracking, then you have to resample the audio. But for ISS, you don't need to resample the audio. Where can we get the frequencies for the different satellite? So you can simply Google the frequencies for the different satellite. You can put the name of the satellite, and you will get the frequencies. In a MMSS TV, even if I play the signal from a different device, it doesn't receive. So probably your sound input of the device is not changed. So you have to change or give your sound input in MMSS TV by going in the option and set up MMSS TV. So here you have to give your input device. So the input device here is microphone, and you have to also change the input device of your system. So go in the setting of the systems and change the input device for system. Also the input device for system is also should be similar, or output device for the system should be similar to the input device of the MMSS TV. So probably that can be a problem with you. So I think there are no more doubts. So we have decoded the images. I hope you have enjoyed this process of decoding the image and recording the audio using webSDR from the ISS. And yeah, so we also have the social media handles, so you can follow us on the Instagram, Facebook, and you can also read the blogs on the wordpress.com. On the Instagram, we have some interesting series named Morse Mania. So in that series, we are telling about the more about the Morse code. So if you are really interested in learning the Morse code, you can follow that series, and the series is currently running. So and we are posting some interesting questions about the IIT Bombay and questions and the facts about the IIT Bombay. So if you are the first year student at IIT Bombay, then this will be really good for you to know the interesting fact about our institute. And we have also some other series like on the Instagram named Know or Check. In that series, we told about the ground station. So if you want to know more about the ground station, you can follow that series, know or check, and can read out all the posts of that series. On the Facebook, we provide Facebook page. We have our own Facebook page of the Ham Radio Club IIT Bombay, and we provide some information about the sessions and the activities we do. So you can like that page. And on the wordpress.com, we have blogs related named transmission tales, communication chronicles. And if you are new to the amateur radio community and ham community, then we have the ham 101 blog that will tell you the basics of the ham radio and the amateur community. And the second part of the ham 101 is related to the satellite tracking. So if you want to know more about the satellite tracking and want to know the things we have discussed today, you can also read that blog. And yeah, yeah, if you want, if you want to know more about the ground station, then we also have the ground station workshop that will probably happen in the January of the next year. So you can also attend that workshop. You really interested in knowing more about the ground station, then I recommend you to attend that workshop. And if you are new, then I recommend you to read the Hammer novel blog. So we also have some group on the WhatsApp named IITB Ham Radio Club discussion forum. So you can scan this code and join that WhatsApp group, and there we will discuss the doubts. And if you have you have faced some problems in today's session, we can also discuss that in that group, and you can connect to us. That that group. And if you are unable to scan this QR code, then the link for the WhatsApp group is also given in the description. So you can see the description, and from there you can get the link for the WhatsApp group, and you can join the WhatsApp group. And we have also some informal session on the WhatsApp group of the tracking. And so if you join the WhatsApp group, we can have some tracking session on the Zoom, or we can discuss your doubts. And the transmission of the images from the ISS will be continued to 31 December. So you can find the passage using the antoio.com, and after that you can receive the signal using the webSDR of the South Africa, or you can use the another webSDR, because there are 75 webSDR available for the same frequency, 145.8 megahertz. So you can choose either of these webSDR and can receive the signal, and that you can decode that signal using MMSS TV. So image and the audio will not be perfect every time, so you can direct and try till 31st and discuss the doubts. And if you want some short information informal session, then we can also have the informal session. And if you receive good image, then you can take the Ham Radio Club IIT Bombay and post that image on the Instagram or other social media handles. So now I am going to tell you about MMS TV if you have some doubts. So, so I am repeating the MMS TV things in the last. So you have to go in the option, set up the MMS TV. Then you have to choose your sound, yeah, input sound device. So you can either choose phone, or if you, yeah, or you can choose it to default. So I am choosing to microphone, and after choosing this, you have to use your mobile phone or other device to play the sound on it, and play the sound on the mobile, and keep the mobile near to your laptop, and click in the RX mode. And RX mode should be auto. You don't have to specify the RX mode. It will by default specified if you select the auto. And after that you can play your audio near your laptop, and the image will be decoded. So that's all about the tracking the ISS, and tracking the ISS using the online tracking. And I hope you guys enjoyed this session. Thank you.